Alright, geometry, we're looking at the notes for Unit 9, which is all about circles, and we're starting out Part 1 out of 6. We're going to be looking here at Section 11.1. You guys should have already started the reading strategies. This is more just kind of going over them, and then I'll go through the problem solving, and then you guys will do the review for mastery as well. So, here we go. Reading strategies. So, it's just vocabulary. We got this thing, a secant line, a chord. We have a tangent line, a point of tangency, the interior, exterior, and perpendicular, radius. We got all this stuff going on. You have that information there. I'm here just to make sure that you're on point with them. So look, let's see what we got here. The blank of a circle is a set of all points inside of a circle. So the inside would be the interior. That was easy. A blank is a line that intersects a circle at 2 points. Okay, so intersecting it twice, that means it's like going boom through the interior. That would be a secant line, or a secant. Look at C above. Why is the line T not a secant? Well, line T. Where's line T? T. Right here. Okay, so it touches the circle here, but T is a tangent. It's touching just at one point. Not at all points, just at the one point. So it's a tangent, not a secant. Because it is a tangent. It only touches once. One time. There we go. Okay. Use circle P to identify the following. Okay, so now what are we looking at? The secant line. Secant line. This looks like a secant line here because it crosses once, twice. So that secant line would be line Z. A point of tangency. Okay, the point of we should say like line Z, I guess. Point of tangency would be right there at B, so point B. The tangent line would be this line here that touches at the point of tangency, or point of tangency, which would be line K. A chord. Okay, a chord is like a secant, except it's a segment where it touches twice, but it's not going through it like a line. It's just a segment where it has endpoints. So that would be segment XY, notated that way. A point in the exterior of the circle. This is the only point at the outside, so that'd be point R, and a point interior. Ooh. Is there one? Yeah, there is. The center, which is point P. Oh, that was a piece of cake. Just vocabulary, knowing what we're looking at. Now, let's look at the stuff that's not a piece of cake. Okay, so we need to try to see what can we do to calculate these things. We got a lot of stuff going on. Let's take a peek at it. First one, the cruising altitude, that's kind of like a height of a commercial airplane, is 9,000 meters. Okay, use the diagram in this distance to find AB, the distance from an airplane at cruising altitude to the Earth's horizon. Okay, so they're asking for this side right there. We don't know what that is. But this says 9,000 meters. Now this is a little deceptive because if you notice these units here, it says 6,371 kilometers, which means 6,371,000 meters. So this isn't very accurate because it's implying that this right here is 9,000 meters. That's only 9 kilometers. Okay. So here's what we see. Here's what I see at least. I see that this radius of the circle is 6,371 kilometers here as well as here. So for me to find this AB, I've created a right triangle, and I have two sides of it. It's not exactly obvious, but here's kind of the breakdown. So I got the 6,371, and then let's color code this. This radius, I'll color blue, is the same as this radius here. So this blue part is 6,371, just like this blue part. But then that red on the end is another 9. So we got the 6,371 plus 9. So altogether that makes 6,380. So the whole piece, when you combine both of them, is 6,380. Okay, so we have a hypotenuse. The hypotenuse is 6,380. We got a leg that is 6,371, and we basically got to find the other leg. And this is really just a Pythagorean theorem. So let's calculate that. It's going to be, we'll call this AB, we'll just call it x. So x squared plus, what else do we have happening? Plus 6,371 squared equals 6,380 squared. Oh, that's going to be some big numbers. Here, I'm going to shortcut a little bit for this. So we know that we're going to subtract that 6,371 squared from the 6,380 squared. So I'm going to do 6,380 squared minus 6,371 squared. Then we need to square root that. So I need to do second, then the square root, and then the answer that we just found. And that's 338.7, 338 kilometers. Okay, so x equals 338 kilometers. Well, that's a lot further than I was thinking, actually, so that's kind of cool. All right, let's look at number 2. In the figure, segments that appear to be tangent are tangent. Find QS. Oof, all right. QS would be from here to here, all the way. Well, I know that 2y plus 9 is the same as 15, because two lengths that are tangent are also equal to each other. So 2y plus 9 is equal to 15. That could help me figure out the value for y. So let's see what that gives me. 2y plus 9 is 15, subtract 9, gives me 2y equals 6. Y is going to be 3. Okay, so that means this right here is 15, of course. And then down here, though, this is going to be 4 times 3, which is 12. Okay, so we got 15 and 12, 15, and then this would also have to be 12. Because here's why. QU, to go from Q to U, is the same as to go from Q to S, because those are both tangent 2. So 15 and 12 is going to be the same on both of those. So what's the total with 15 and 12 put together? It's 27. 27 would be your answer. Too easy, too easy. Let's do another problem solving here. A couple more. The area of circle H is 100 pi and HF equals 26. What is the perimeter of quadrilateral EFGH? Okay, so first, when it says the area of circle H is 100 pi, remember that the area of a circle is pi times the radius squared. So they're telling us that that's 100 pi. Well, we can kind of work backwards here, because if we divide by pi, then we got 100 equals the radius squared. That means that r was originally 10. So this piece here, HE is 10, and this piece here is 10 as well. And it says HF is 26. Now look at this. I got some right triangles because I got leg and hypotenuse. We'll call this x, and hey, guess what? GF is the same, so we'll call that x as well. So that means x squared plus 10 squared equals 26 squared. Alright, well that's 100. And what's 26? That's going to be pretty big. Let's see. 676. So we got some more algebra to do. We subtract 100 from each side. Then we got 576 equals x squared. So we need to square root 576. So second square root 576. That gives me, whoa, comes out perfectly. It's 24. That's kind of cool. So this is 24, as is this. So now for the perimeter of the whole thing, if I'm looking at it, this piece 24 plus another 24 plus another 10 plus another 10. So we got 20, 44, and then 68. So 68, because it was 10 plus 10 plus 24 plus 24, which altogether makes 68. Alrighty. Let's see what we got going on here. IH, there, blah, blah, blah. These are all tangent. What is IK? IK. Okay, so for me to figure out IK, I gotta figure out this piece as well as this piece. Fortunately for me, I know that when two pieces are tangent and they come together at the same point, like this one and this one, they're equal. So that means that 6x minus 3 equals 5x plus 1. Do some algebra. Add the 3. We got x equals 4. Okay, so x equals 4, which means this would be 5 times 4 plus 1, which is 21. Okay, let's look at the other one. It says 4y plus 2 equals y squared minus 10. Oh, this is going to be a little bit harder. Y squared minus 10 equals 4y plus 2. All right, let's see what we can go off of here. I'm actually going to do kind of a tricky way of doing it. Not one that I suggest to everybody, but it's kind of interesting. So I'm going to add 10 to each side and then subtract 4y. You'll see why here in a second. That'll give me y squared minus 4y equals 12. Well, I could factor out a y times y minus 4 equals 12. Now I just got to think of a number, and then that same number minus 4 multiplied would equal 12. Well, let's see. We know that 1 times 12 equals 12, but 1 minus 4 is negative 3, so that doesn't give me 1 and 12. Let's write 2. 2 times 6 equals 12. 2 minus 4 would be negative 2, but wait a second, if I switch that around, 6 times 2, so that means like 6 times 6 minus 4, look at that, so that means that y must equal 6. You know, just a little bit of guess and check there, and I figured out y equals 6. Okay, so on the other side it says 4y plus 2, so it's 4 times 6 plus 2, which is 24 and 2, that's 26. So I got 26, 21, put those together, and you got 47. Booyah. Let's do some more. Now we're into the multiple choice, I believe. Here we go. A teardrop-shaped roller coaster is this loop-de-loop thing. And the radius is constantly changing. The radius at the bottom of the loop is much larger than the radius at the top of the loop. So like right here, this radius is a lot longer than this radius. If that makes sense. Which is a true statement. K and M have 2 points of tangency. I don't know what that means. Oh, 2 points of tangent? No, they intersect, but those aren't tangent points. No, they don't. They don't even have 1 point of tangency. L might. Yeah. Oh, wait. L is internally tangent to both K and M. I would guess so, because that's saying like this kind of sits right inside of each of those circles, and that is probably one of these. We're not exactly sure on the vocabulary here, but definitely would be one of those. All right, let's look at this. G, I'm going to say internally, by the way. I'm going with a hunch there, because I think external means like this, and internal means like this, where it's one inside the other. And L is internal for each of those. G has a center 2, 5 and a radius 3. H has a center 2, 0. If the circles are tangent, which line could be tangent to both circles? Okay, so I need to draw a little picture here. It's a center at 2, 5. So 1, 2, 1, 2, 3, 4, 5. And it's got a radius 3. So I'm going to go down from 5 minus 3 would be down to 2. So there is like a circle. Oh, that's not a very good drawing. About like that. That's a little better. And H has a center at 2, 0. At 2, 0 right here. So the only way that it could be tangent is if it had a radius 2 and it had like a little horizontal line going in between them. Right here at y equals 2. Oh, well that's the answer right there. Not the other one. The Hubble Space Telescope orbits, or goes around in circles, because we're talking about circles. 353 miles above Earth, and Earth's radius is about 3,960 miles, which is closest to the distance from the telescope to the Earth's horizon. Alright, I think we need a picture, because I'm already confused. The Hubble Space Telescope orbits 353 miles above the Earth. So here's the Earth, and here's the telescope, and that's 353. The Earth's radius is about 3,960. So if we keep going down into the radius, it's 3,960, which is closest to the distance from the telescope to the Earth's horizons. Oh, so we're doing that same thing like the rocket ship where 353, 3,960, 3,960, and then we add those together. Well, let's see what those are together. 353 plus 3,960. Oops. That's 4,313. So this right here is 4,313. To go all the way from the telescope through the Earth down to the middle. And then if we go out the Earth to that tangent point here, we would have 3,960. And then this is 4,313. So we have to do this Pythagorean theorem again. But I'm going to just, should I guess it? No, let's not guess it. Let's go ahead and actually do it. I'm going to do this. I'm going to cancel this one out right away because there's no way that it could be that, because the hypotenuse, the 4,313, would have to be the longest side. Okay, so we got to figure out the square root of 4,313 squared minus 3,960 squared. What am I doing here? Well, this is like my c squared, and this is like my b squared. And I know that a squared plus b squared equals c squared. So if I move the b over here, then I got c squared minus b squared equals a squared. Then I square root everything, and I'll have a equals the square root of c squared minus b squared. Okay, so that's what I'm shortcutting over to there. So I can type it. So I'm going to do second square root, then 4,313 squared minus 3,960 squared. Let's see what we get. 1708. So the answer would be B, 1709. Okay, at this point, you guys are going to pause video. I'm actually going to stop this video. And you're going to be selecting Part 1B next. To see the review for mastery. But take a pause here real quick. You guys take a shot at the review for mastery, then I'll go over it with you.